Alright, in this video we're going to look at one example of implicit differentiation, and then also we're going to find the equation of a tangent line at a specific point. So for implicit differentiation, the function y is a function of x, and we may or may not know what it is explicitly, but when we take the derivative with respect to x of y, y is a differentiable function of x, and so that's going to give us dy over dx. Okay, so we're going to go ahead and perform implicit differentiation on this equation here. Negative 51x the fourth plus 9x the 51y plus y to the eighth, and that's going to be equal to negative 41. So we're going to be taking the derivative with respect to x here. So we're going to go ahead and rewrite it. And I'm going to go ahead and take the derivative of that. So we're going to take the derivative of negative 51x the fourth. So you're going to bring down the form. So negative 51 times 4 is going to be negative 204. Subtract 1 from the exponent. It becomes x to the third. We do have a product here of x to the 51 times y. So you're going to use the product rule. So you have 9. And then we're going to go ahead and take the derivative of x to the 51. So the 51 comes down, so 9 times 51 is 459. Subtract 1 from the exponent, x to the 50th, and then times the second function of y, plus the first function, 9x to the 51, and then derivative of y with respect to x is going to be dy over dx, plus the derivative of y to the eighth with respect to x is 8y to the seventh dy over dx, and that's your chain rule there. And that's going to be equal to 0. Okay, and they want us to find dy over dx, so we're going to come up with an expression for dy over dx. So notice that these two have dy over dx. We're going to factor dy over dx out of those two. So you have dy over dx times 9x to the 51 plus 8y to the 7th. Okay, and then these two terms are going to move over to the other side of the equation. Remember, the derivative of the negative 41 as the derivative is constant, that's going to be 0. Okay, so we're going to add 204 x cubed, and we're going to subtract 459 x to the 50th y. Okay, so we're going to add 204 x cubed, and then we're going to subtract 459 x to the 50th y. And then we're going to divide by 9x to the 51 plus 8y to the 7th. Okay, so just divide by the coefficient attached to the dy dx. There we go. And that is our dy dx. It's our slope generating function. So if we wanted to take various points on the line, or on the graph, excuse me, we could tell you what the slope of the tangent line is at those points. Okay, so let's go ahead and we're just going to rewrite our derivative because we're interested in coming up with the equation of the tangent line at the point 1, 1. So we just rewrite our derivative here. Okay, and then we were specifically asked to find the equation of the tangent line at 1, 1, so we need to know what the slope of the tangent line is at 1, 1, and so that's evaluating the derivative at 1, 1. Okay, so both the x and the y's, we just substitute in 1 for both of them. And simplifying that down, negative 255 over 17, which is going to reduce down to negative 15. And that's the slope of the tangent line to the graph at the point 1, 1. We're going to use the point slope formula to come up with the equation of the line. Y minus y1 equals m times x minus x1. Okay, so there's your x1, y1. There's your slope. So we're just going to need to drop that in and solve for y. Y minus 1 equals negative 15 x minus 1. Solving that for y, we have y equals negative 15x plus 16. Okay. On the next two pages, we'll go ahead and take a look. Okay. So I used Desmos to go ahead and plot the graph here, so it's kind of a crazy looking thing. And then I went ahead and put in the point 1, 1. So there's your point 1, 1 there, okay? And so the tangent line's probably going to look something like that, okay? And you know, it might be easier to deal with the tangent line than it is for the actual function. The tangent line, as long as you're relatively close to 1 on the x-axis, the y values are pretty close, and so we could use the line to make some approximations. For example, here it is with the tangent line on there, so you do see its tangent at the point there. And that's it, really. So we'll see you next time.